Hello everyone. In today's video, I am going to discuss about how to implement the solution to the sum of subset problem using backtracking. If you are watching this video for the first time, I would recommend to watch my previous video wherein I have discussed as well as I have traced how exactly the sum of subset problem can be solved using the backtracking approach. Now coming to the C program, I have included the header files stdio and stdlib.h. Now in the main program, I will be calling the sum of subset function. So what I will do is I will declare some variables as global variables. So the variables are, first one is w, which denotes my set S. If the Boolean array X, which tells whether the element is the part of subset or whether the element is not the part of subset, and D, this is my max value that I am going to get in order to when I add the elements in the subset. Now let's start with the main function. Now in the main function, the elements that we'll have are variables are ni, let it be ni. In case if I require some more variables, we'll add it later. First we'll read the number of elements. Printf read number of elements. That is nothing but my n. Now after reading the value of n, I will read those elements in set w. I just put a remark in printf that read elements in increasing order. We know that the elements in set S should always be in increasing order. I take a for loop for I is equal to 1, I less than or equal to n, I plus plus, scanf percentage d ampersand of w of I. Now what I will do while reading this w of I will put those elements onto sum, so that when I call my sum of subset problem, the last argument to my sum of subset function, I should have this sum variable as the argument, as the value. Sum is equal to sum plus w of I. Oh, condition, sorry. So what I have done, I have read the number of elements, I have read the elements in the increasing order. One more input is I need to read the subset max value, which is nothing but my d. Scanf percentage d ampersand of d. D is declared yes, w is declared yes, sum is also declared. Now what I will do, I will, if the entire sum on adding, if it is less than d, if the entire sum is less than d, and one more condition. What is the other condition? I have not used and, I will use or condition. Either this might be true or the other condition is if weight of the first element itself is greater than d, then printf no solutions. Let me check once again. If the summation of all the values is less than d, then I can't get the subsets. Or if the first element itself is greater than d, I can't get the subset. So I close this. If not, I will call the function. Sum subset. Please note that I am writing the function as sum set. After this, it is a sum subset of 0, 1, comma, sum. I am passing 3 arguments. Initial sum value. So, initial value, I will call this as S, okay, which is 0. And this is index K, and this is my final sum. If you remember the state space tree, I was just passing only these 2 arguments, 0 and the total sum. I was not passing this K, return 0. Close the main function. Close the main function. This is one part here. After this is the continuation. This was about the main function. Now let's go for this sum underscore subset function. So is it returning anything? The function is not going to return anything. Hence we need to have the return type as void. And note that there are 3 arguments. S, K, I will call this as R. Because in the algorithm we have used it as R. I will call it as R. Coming to that function return type as void, sum underscore subset int s, comma int k, comma int r. Now within this function, let me have 2 variables. One variable by name I and one more by a variable by name b as a static integer, and I will initialize this b to 1. Now this b is basically for the number of subsets. Number of subsets. Now what was the first step that we were supposed to do? First mark the first element k was passed with 1. It is been initialized to 1. Now if s plus wk is equal to d, if this condition was true, it implies that I have come up with one subset. Printf subset percentage d. What is this? This was nothing but my b plus plus. Now take a for loop for I is equal to 1 to k. If x of I is equal to 1, print percentage d a tab plus print w of I. This was one condition. Let me check once again. S plus wk is equal to d. I am into this. I got check. This was maybe in case of the algorithm. If you have noted that if s plus wk was equal to d, I would have used a statement to print x of 1 to n. So this is I am printing. Now if this condition is not true, the other condition might be if s plus wk plus 1, if this whole thing is less than, if whole thing is less than or equal to d, I used to call the function once again sum underscore subset, sum subset of the arguments yes plus if this condition is not true, if there were two conditions. The first condition was s plus r minus wk, this was greater than or equal to d, and one condition. Second condition, s plus w of k plus 1 less than or equal to d. If any of this condition is true, call some subset of s comma k plus 1 comma r minus wk. Close this function. This should be fine. This was about how to implement the sum of subset problem using backtracking approach. Thank you.